And welcome back. Now, have you ever wanted to make an LED cube? Something like this, or, well, probably a little bit bigger than this one really. This is a 2x2x2, which means, you know, 2 LEDs wide, 2 LEDs cross, and 2 LEDs deep. Now, you wouldn't normally build something like this other than for demonstration purposes, which is what I've done. You'd normally want a 3x3x3, which gives you a little bit more scope. However, this video is all about how and why this works the way it does, and if you want to understand that, the 2x2x2 is the best possible size you can make, because everything that happens here happens on a bigger scale for those larger cubes. And anyway, you wouldn't want me having to create a 3x3x3 just for the purposes of the demo, would you? It would be so much work, it would be almost impossible. You know, something like this, for example, that would just be too much work to put together a 3x. Oh, yes, that's that one. We'll come on to this quite a bit later, I think. This is a 3x3x3, and as you can see, it's running quite happily, although I haven't actually darkened the glass LEDs yet. You notice these ones over here, they're sort of red. Well, that's actually red nail varnish, would you believe? Because as you can see here, these ones here are crystal clear, which looks fine in real life, sort of, but it doesn't stand out on camera very well. So these are going to have to be coloured in. Anyway, that's a 3x3x3, but you won't know how to do that, or at least you won't understand what's going on with that until we've completed this one here. So we're going to concentrate on the 2x2x2, and I get a feeling we're not going to squeeze all this into one video, so I'll split it with something in the middle perhaps. So this is a 2x2x2. Now let's have a look at the aspects that we're going to have to consider. There's the actual construction of this. Now the internet's full of how to do it. I'll show you how I did it, which is pretty much along the same lines as everybody else. And the circuit diagram, which is this one here. Well, this is the circuit, not the circuit diagram. I'll show you that. And it's important that this bit gets done first, but this is simple. Even if you're not very good at electronics, or you're unsure or unfamiliar with it all, the actual electronics is pretty basic and straightforward. Follow my instructions and you'll get this up and running. Actually getting the sketch to do this, of course, is a bit more detailed, but then again, you've got a head start, haven't you? Because you can just download my sketch, or sketches, I should say, and get something up and running. And then understand, perhaps, how this works, because getting this to work wasn't the simplest thing in the whole world, because I built this from scratch. I mean, yes, I had a quick glance around the internet to think, how do they get this to work, and what are they doing here? How many LEDs are they lighting up at once? So I had a quick look, got thoroughly confused, but I did see huge listings of byte arrays, that is binary representations of either characters or integers. And I thought, you know, that reminds me of my large LCD byte array. And I thought, I wonder if that's how they do it. Anyway, I've developed this from scratch, and as it happens, once I've developed it, I had a look around the internet, and from what I can gather, it's pretty much how everybody else has done it as well. So let's start off with the 2x2. It looks a lot more complicated here, of course, always does, doesn't it, when you do it in a mess like this, but it's pretty simple, and I think you should be able to knock this up within about an hour or so. And having knocked up a 2x2x2, then comes the fun part of actually understanding how it all hangs together. And once you've understood that, you think, now I'm ready for that 3x3x3, that one over there, which I will put some red on so we can see what's going on. And I think it'll be quite fun to do. Well, it was quite a learning experience for me actually, because I sort of understood in principle how this might work, but until I actually did it, and made a few mistakes along the way, don't get me wrong. I think the sketch is currently marked as Mark 4, so it took me 4 attempts while I was doing it, and I'll explain the thought processes that went into it as well. As I say, time is of the essence, so let's get on and let me show you how I put this together first. Right, let's consider how I made that little cube at the back there, flashing away. The internet suggests, there's quite a few people who do it this way, is that you get a little board like this and you mark out a grid like this, spaced the way you want it. So all I did, this is a 3mm hole because these LEDs are 3mm. So if you've got 5mm LEDs, obviously you want 5mm holes, and they're a fairly snug fit, which you want because you don't want them moving about too much when you're soldering. But on the other hand, you don't want them so tight that you can't get them out once they have been soldered. So make sure they fit in fairly easily. So let's zoom in on this little bit down here, and we can get a better idea of what's going on. Right, so there we have the matrix of, yes, okay, there's 9 here because that was the larger one, but we're just going to concentrate on these 4 here. So as you can see, if I put an LED in here, this is going to be tricky doing this on the camera. So it just fits in there like that, okay? Nice and snug, but not too snug that you can't get it out. Now, an LED, any LED, has got a long lead and a short lead. The long lead is always the anode, that is the one that must be made positive for current to flow. And the short lead is the cathode, and it's the one with the bar. And in fact, if you can get really close in here, let me have a look, you might just be able to make out that that's got a flat on it. So how do you remember this? I mean, there's a very easy way to remember which way around an LED goes, and I'm going to draw you that right now. So let's have our LED on here. So this is our LED, and it's got a long lead and a short lead. Okay, done a little bit exaggerated here, but that's pretty much how it is. Now the long lead is the plus. So if you look at the electrical symbol now, electrical symbol for an LED is like this. And in fact you would have a little couple of arrows out to show that light's coming out. So this is the plus, this is the minus. How do you remember which one's which? Well, if you think about this bar at the top, that sort of looks like a minus, doesn't it, when it's held the other way up? So that's the way to remember it. The bar that looks like a minus is the minus cathode. That must go to a negative supply, which means the longer lead, the one without the bar, has got to go to the positive, right? So in fact, if you were to draw this into a circuit, your positive battery would be there and your negative battery would be there, and that's how it would work. Now if that were a 3-volt battery, you might just get away with that, but it'd probably blow it up. So somewhere in here you'd have some kind of limiting resistor, probably something like 150 ohms. Okay, now the flat on that LED, as I say, if I try and draw this in 3D terms now, what it is, it's round and then it's got a little flat on the bottom. And you have a lead there and a lead there. That's the long one, that's the short one, so that's the positive. So this one, where you've got the flat, and the flat is like a bar, which looks like the bar there, which it looks like a negative, right? So that's the negative. That's how you can always determine it. The lead closest to the flat bit is the lead closest to the cathode, which is that one there, which is the negative. So that's the way to identify an LED. To be quite honest, the way I do it mostly is looking for the long lead, but if you've trimmed an LED already and they're equal lengths, then remember it's the lead closest to the flat bar is in fact the cathode with the bar here, right? So that reminds you of that, and that line looks like a minus sign, and therefore is the cathode. It's got to go to the negative side of the battery. There's the plus, there's the minus. Okay, so there's a little mnemonic for you, so you can always remember which way around an LED goes. Right, now back to construction. What you do then with each of these LEDs, you take the long lead, which is the anode, right, and you bend it pretty much at 90 degrees to the body like that, okay, because you're going to be soldering other LEDs to this. And then what you do, you make sure that the cathode, the one sticking out, is always at the outside of your little square. So in this case, for example, we put that in there, and as you can see, that goes across there quite nicely, and that is going to form part of the column. All right, so if I go to this one here, let me just bring that into shot. These upright bars going all the way up here are in fact made up out of these vertical ones here, and these ones are all going to join together. So if you get another one, get the long bar, just bend it 90 degrees. Now remember, the cathode, the one that's left vertical, is going to form part of the column, and always put it on the outside. So when this goes in here, like so, I know this is looking a bit cack-handed because I'm doing it with the camera in a way. So just moving the camera across the top now a little bit so perhaps you can see it better. So what we want is this vertical one to stay away from this one here, because that's going to get soldered to there, and this one is going to be soldered to the next one. Remember, we're making a four-way here, right? So all you do is dab your soldering on the junction here so that you're creating a square, and these vertical ones will be connected to the vertical ones on the next layer you make. So remember, you're going to make two of these. Right, that's looking okay. Let me just move the camera around so you can get a better 3D view of it. If I move it down like that, there we are, look. So we've got the uprights here. This is an upright, and this is the flat moving across to the next LED. So let me just put that one in and show you how that's going to work as well. Right, so I've bent this one at 90 degrees. That goes in here. That one there. That one there is soldered onto the one there. And I think you can already see, look, it's already forming. It's already forming a nice little square. And you only need the tiniest blob of solder. Make sure it does solder though, you don't want any dry joints. And that will make the frame, if you like, that is going to be a common anode. Alright, so you're turning this into a common anode effectively. All your LEDs, anodes are connected together, and that will be connected to one transistor. You need one transistor per layer. Another reason why we're doing a 2x2x2, because you do need a transistor per layer, so let's not make this too complicated. We'll just have two transistors. So these vertical ones are going to be joined onto the vertical of the next layer in just the same way. And you may need to bend just the top of this over a little bit. So I'm just going to do that here. Just bend it. See, just a tiny little kink like that enables you, when you get your next LED, when you make your next layer, so make one like this all the way around, make another one, so they're two independent layers now, and then you have to place one on top of the other. So I'm going to pretend this is now another layer with this. So as you have now another layer on here, that bar, that vertical column, has got to be soldered onto this one, and you want it as high as possible, a bit like that. Just dab it on there, bink, and it's done. And that's how you build your layers. Okay, now if you're confused by that, there's plenty of stuff on the internet, but if I go into any more detail, this will be a half-hour video on how to construct this rather than what's going on inside the code. Right, so I'm going to leave it there. I think you can probably figure that out. To test it, by the way, when you've made each layer, connect just a 2 volt or 1 point. You won't get away with a 1.5, it's not bright enough, you won't see anything. You do need a 2 volt or a 3 volt with a little resistor. 3 volts with maybe, I don't know, a 50 ohm, 47 ohm resistor in series. The positive to this, so it's connected all the way around, it'll automatically do that, and then just put the negative onto each one of these, and you'll see that each one will glow in turn. And when you've done it to both layers and put them on, do the same sort of test, and you'll find that each one of these will glow depending on which one of these you touch and where you've connected the positive to, whether it's this layer or the layer up here, the next layer, not shown here of course. Okay, so that's how you connect your little thing up. Next step is to know the actual circuit diagram, how to put the circuit diagram together to power all this up. That's coming up next. Right, let's talk about the circuit diagram. Now I've drawn out the cube as it should look when you've finished it. Right, so effectively you've got your two layers like this that are independently connected. You don't need to put anything on here just yet. And you've got your 4 columns. All right, and this is how you test it by putting a little 3 volt battery on here. In fact, this is incorrect, this diagram. This battery should be shown with the longest bar at the top because it's positive, and a short bar at the bottom there, and that's negative. That's much more like it. Right, so that's what it should look like, and let's have a look at the circuit diagram next. Right, here's the entire circuit diagram now. You've made, or should have made by now, your cube, which is, you know, demonstrated here by all these different colours, and your columns coming down will be connected in 2s. And if you think this looks a little bit confusing, believe me, when you've done it, when you've actually connected them all up to look like this, it will become obvious. It's not rocket science, and you can do it. So just this will probably take you, if you've never done this before in your life, it'll take you about an hour, And if you're good at electronics and you know about connecting stuff up, it'll probably take you about 20 minutes. The other thing is, when you're putting this together, you'll be tempted to hold things with your finger and thumb as you're trying to solder things, and then let's assume this is my soldering iron, then you'll be dabbing solder on and burn your fingers. So what I use are these things here. Look, these are for, I know you find them in bank tellers, you know, for flicking through notes. So if this was a pile of notes, it allows you to flick through them quickly like that. Right, I don't know what they're called. I don't know. You'll have to look on in Staples or somewhere, or some office thing. But you put one on there and one on there. Now, you don't end up with a lot of feeling in those fingers, but that's precisely what you want. It means you can hold your components in while you're soldering, and of course the heat won't go through your fingers and burn them. All right, that's a little trick that I've been using for several years. If you try one, you'll end up using this finger because you've got more feeling in this finger. You'll be pushing the component and you'll burn yourself. Don't ask me how I know that. Okay, so this circuit then, we've talked about the cube enough, I think. You need 2 transistors like a BC548 or similar. Any NPN transistor will do for this really. 150 ohms I'm using into the emitter to power an entire layer. This is not how we're going to do it if we did a 3x3x3 cube, but for this demonstration purpose it's more than enough. So 150 into the emitter, 10k into the base. So the base is connected into 2 GPIO pins of your choice, and the 4 columns are connected into a GPIO pins of your choice as well, whichever ones happen to be to hand really. Doesn't matter, because whatever you're choosing here, but I would keep them sequential. So for example, if you're choosing C1 as pin, I don't know, 3, then make sure that's pin 3, pin 4, pin 5, pin 6. Otherwise your code might look a bit odd. And similarly with these two, just choose any 2. Okay, so that's the circuit. Really simple, not a lot to it. And of course you can test all this without anything happening on here, just by connecting up a 5-volt supply here and dabbing this end here and this end here to the 5 volts, and each one of these to the ground, and you'll see all these bits lighting up before a sketch has even hit it. But don't worry about that, because what I've got a couple of test sketches that simply test your wiring really to make sure it's all correct and they're not operating in a funny manner. Because obviously, as you can imagine, if you were to wire it somehow incorrectly, you get a couple of these switched around the wrong way, well, you'll wonder what on earth's hit you when the sketch runs, because they'll all be doing funny things. So there's a couple of sketches just to test out your wiring. And as I say, to get all this running, I don't know, if you're into electronics, it'll probably take you an hour or 2. If it's all new to you, then allow a full evening and do it slowly. This is why we're doing a 2x2x2, so that you have time to think about what it is you're doing and not rushing it and trying to do 27 LEDs. And that's just ridiculous for a beginner. But I think you'll be able to cope with 2 layers of 4 LEDs. Okay, so that's the physical and theoretical construction. How you put it together on your board is up to you, but just follow this output. I mean, let's face it, you've only got 1 resistor there, 1 resistor there, 1 there, 1 there, and 2 transistors, and that is exactly what's shown here. But I'm not going to put this layout on, because obviously that's my layout and it might be very, very different to you. Transistors, as I say, any NPN, BC548 or similar, 2N2924, something like that. Okay, so that's that bit. Right, now we've covered all that, let's have a look at another stage. Right, let's assume that you've actually got the hardware built and you've tested it, and I would recommend and urge you, if you're going to put this together, take your time. It's not difficult, but it is a bit fiddly, and of course you can test it very, very easily with a 3-volt battery, you know, one of those little round button batteries or something like that, or 2 AA batteries, just to make sure you get the resistor in the right place so you don't go and blow the LEDs up. And as I also mentioned at the beginning of the video, I used initially crystal clear LEDs. These are all clear. I've had to put red nail varnish on because otherwise they didn't really show up that well. So I'd say use 3mm or 5mm red LEDs. In fact, you could even use a different colour per layer just to sort of, I don't know, demonstrate what it is you're doing. And in fact, in hindsight, I probably would have done that. I'd have used green at the bottom and red at the top. Because looking at this now through the camera lens, it's sometimes a little bit difficult to know which layer's which that's lighting up. You just, I don't know, I guess I'll have to hold it a little bit differently like that perhaps. Anyway, that's just my experience. So it's time now to look at the code. Assuming you've got something that's up and running hardware wise, you need a bit of program, don't you, to actually make it run. So let's have a look at the code window. Right, so this is a wiring test. I believe this is what I called it. Yeah, this is the wiring test number 1. So it's about as simple as you can get, just to prove that what you've put together is going to hang together. Okay, so let's just whiz through this in a little bit. So at the top we're saying, right, layers. I've connected my layers, that is these square things on the actual diagram. So it's this layer here and this one down the bottom. You remember those legs that we turned at right angles? They are what I called a layer. So on the diagram, what we're talking about as a layer is this layer, this right angled square that is an independent layer. Okay, so layer 1, layer 2. In the code, I've connected those up to pins 3 and 4. And then the columns, that's the vertical ones, I've connected them up to 8, 9, 10, 11. It's not really critical which columns you connect them to, but well, you've got a choice. You might as well connect them up the same ones I have, I reckon, don't you? Okay, so we start the serial window, just debugging so you can put a few bits in. All we're doing here is making sure that each of those pins is an output pin. And that's for the layers, and this is for the columns. Now the columns, you just have to remember this, the columns allow current to flow into them, right? So the Arduino is syncing the current, it's not sourcing the current. The source of the current comes from the layer. The columns sync that current. Therefore, in this bit of code here, what we're saying is, if the column pin is low, it will allow the current to flow. If it's high, it puts up a stop sign. No, it's high, you're not coming in, stops the current flowing. Okay, just something to bear in mind. And what we're doing here, the reason why we're putting these pins into an array like this is so that we don't have to keep referring to pin 3, pin 4, pin whatever. We ignore all that. We just go the 0th, the first, 0, 1, 2, 3. So we're not really bothered about which pins they're connected to. It's just the logical first, second, third, fourth pin column, for example. Okay, so that's why we're using this construct here, where we're accessing the array both for the column and for the layer. Right, moving on then to the loop. And as you can see, this is a particularly small loop. We're saying let's run a loop within a loop. Yeah, so for the count of however many layers there are, so we're using an unsigned int. Now the reason I'm using unsigned int, rather than just saying int, if you don't specify it, the compiler will assume you mean a signed integer. All right, now as you know, an integer takes up 2 bytes, but if you have an assigned integer, you get a range of minus 32,000 to plus 32,000. Now for our point of view, it makes no odds at all. But if you have it unsigned, then the minus bit goes away and it goes right up to 65,500 and whatever it is. Okay, so I think it's good practice to always put unsigned if you mean unsigned. If you're not bothered, then put signed. Just a personal preference of mine. So what we're saying here is we're making, first of all, a layer high. So we're allowing current to flow in the first layer, whatever pin that's connected to here. And we're just outputting it on the serial window as well. And then we're saying for the columns, once again, we're having a loop within a loop here. And we're saying switch particular column on, wait for a quarter of a second, and then switch it off. Now remember, on means low, allow the current to flow. Off means high, drawbridge comes up, it's high, you're not allowing any more current to flow through there, right? And then we turn the layer off and output that to the serial window and move on to the next layer, which is here. Okay, so that's only going to do it for 2 layers, that's all we got, and it'll do it for the 4 columns that we have. So what you can expect to see there is a flashing LED on every single pin we got. Let's load this up and get it to work. Right, let's load that up. Off it goes. Remember, I'm not using the standard Arduino IDE for this, so ignore any of these little things you see down here. Right, so that's uploaded now. Yep, definitely uploaded, and let me register my serial port so we can see those things coming out. Right, so there we have some messages coming out already. Let me put auto scroll on so we can see them coming out. So what it's doing now, as you can see, it's displaying each one of the columns and each one of the layers one by one. So obviously it's whizzing around going 1, 2, 3, 4, and then on the next layer 1, 2, 3, 4 as well, and displaying each one of those LEDs in turn. Now that's a good little wiring test, even though it's not the most exciting display ever, but I think if you get this far you'll be well pleased, as I was, just to think, whew, it was right what I did. Well, you never know, do you? You know, you could be scratching your head thinking, now what have I done wrong? So we're leaving the serial prints on for this. Now, as a general note, you should never leave your serial prints in your program if it's in any way speed dependent, which it most certainly will be by the time we get to the 3x3x3 cube. But for a little 2x2x2 like this, it's just not important enough, so we're going to leave these running because that does slow it down quite a bit. You know, these serial prints, especially given that we're running at 9600 baud rate, I mean, it will slow that whole loop down by a considerable amount. But that's in our favour actually at the moment, isn't it? Because you can see these LEDs now quite happily running around. Let me put a real close-up of that. Now you see there we are, and that's pretty clear that it's going around one layer at a time. And what it's actually doing here, I've orientated this wrongly, because if you notice it's starting at the back and then coming to the forward. What it should be doing is that, but these things get in the way then. So let me just, whoa, apart from knocking my camera, let me just move these out of the way a little bit and you might get a better view. So what it should be doing is doing these ones at the front first. So it's 1, 2, then that one at the back 3, and then that one back there 4. Right, that's how we're lighting them up. And then we're doing exactly the same for the top layer. So that's the order: front, front left, front right, back left, back right, and then it does it on the next layer. So that's basically what it's doing. Now of course, if you get the orientation wrong like that or like that, well, of course it will still work as it's working here now, but you'll be confused when we come to actually defining how we want our pattern to display. If you've noticed in the code we've got at the moment that we haven't told it at all how to display any kind of pattern. We can't say turn on column 1 layer 1 and column 3 layer 1, and then on layer 2 turn on column 3 and column 4. We haven't defined any of that yet because this sketch is purely to test your wiring. Get that working, then you can move on to the next one, which I think we'll do right now. Well, maybe not just right now, because we've sort of run out of time, haven't we, on this video. I don't want to make it too long, but it does give you time, if you're going to follow this video, to actually construct the 2x2x2 cube. And of course, if you're watching this sometime in the future, then of course the next video will already be published, so you can watch it straight away. If, however, you're watching this as I publish them, then I'm afraid you're going to have to wait for a couple of weeks or so until I can get the next bit of the video ready, because we don't want to make it too long. Okay, now I hope it's been fun so far. I really hope you do follow me on this cube quest, because as you can see, this 3x3x3 looks really nice. It looks really good in real life. You can't really see the red very much. I mean, if I shield it, you can probably see it a lot better. There we are, look, there we are. So you can see some of the patterns that are being generated on that. And the 3x3x3 really does look nice. But you really need to understand that 2x2x2 first, so that's where we're heading for the next bit. A couple of sketches on how to make the 2x2x2 actually do stuff so that we understand it, so that this stuff here then is just a no-brainer. And it will be, believe me. You do that and you'll understand it perfectly well. Okay, great. Thanks for watching, and I'll see you in the next video. I hope you're finding these videos useful and interesting. Please leave comments down below. Subscribe, share, and give me a thumbs up. Thanks for watching. See you in the next video.